This wanted you to solve and graph the solution on a number line. The first one you should have just divided by 2, both sides by 2, and you would have gotten the answer x equals 3. On a number line, that would just be a dot, closed in circle on that number. The next 4 were inequalities. So these you solve just like equations. You would have subtracted 4 from both sides, getting x is greater than or equal to 1. Because it is greater than or equal to, closed circle on the 1, all the numbers larger. Divide both sides by -3. When you divide by a negative, that sign flips. So it would have gone from a less than to a greater than, and you would have gotten x is greater than -4. Remember, if it's just greater than, you have an open circle at -4 and everything larger. For this one, you needed to get the variables on one side and the numbers on the other and then divide. So you would have gotten x is less than 2 here. Again, open circle on the 2 and everything smaller than 2. This last one, subtract 4, divide by 3. You would have gotten x is less than or equal to 4. Closed circle on the 4, everything that is smaller than 4. So the first thing we want to talk about is what is a linear inequality. We have been doing linear equations for this chapter. Linear equations have an equal sign and they form a line. Linear inequalities have a greater than or less than sign or not equal to. And the graph does have a line, but then it is a set of points. It's not just the set that includes the line. It is actually, you basically split your coordinate plane in half and you are shading parts of the coordinate plane. This is a linear inequality. They're similar to linear equations, but contain inequality signs instead of an equal sign. Then they give you a reminder of what those are: not equal to, less than, greater than or equal to, less than or equal to, and they have an infinite number of solutions. And they show you a picture there. If I have x is less than 3, x is greater than 3, and x equals 3 on a number line, that's what we have there. But let's say I put this on a coordinate plane. Well, x equals 3 on a coordinate plane is that vertical line. Remember, it's a special case. That's x equals 3 on the coordinate plane. So then x is less than 3 would be everything on the coordinate plane that is less than that line, x equals 3. And x greater than 3 would be everything on the coordinate plane that is bigger than 3. And so when you start talking about linear inequalities, then we are talking about a line on the coordinate plane and points that are larger or smaller than the entire line. Let's look at the first example here. The first example is to graph 2x plus y is greater than 3. All right? The first thing we're going to do is we're actually going to switch this to be slope-intercept form. That's the first way we're going to graph these, is slope-intercept form. And so remember, slope-intercept form, when we're doing equalities, are y equals mx plus b. So what we're going to do with the inequalities is we're going to get that y by itself. We will do that by moving that 2x over. Remember, when you move it over, it changes signs. So now we have y is greater than -2x plus 3. All right? We are going to graph this line just like we would if it were an equation. We're going to find the y-intercept on the y-axis, and then we're going to move according to the slope. But then we're going to do something a little bit different. So the first thing we're going to do, find my y-intercept, +3. My slope is -2, which we can write that -2/1 when we're walking, meaning we go down 1 and to the right, or down 2 and to the right 1. All right? But now we have to decide, is this line included or is it not included? And we do that the same way we did on our bell work. We look at this right here. If this were graphing on a number line, would we use an open circle or a closed circle? Open circle. So when we are graphing lines, we are going to use a dashed line or a solid line. A dashed line is just like the open circle. It means the line itself is not actually included. It's just telling us where to start. A solid line is just like a closed circle. It's part of the graph itself, and it's included in your answer. So if you have just greater than or just less than, you will do a dashed line. If you have greater than or equal to, less than or equal to, you will do a solid line. All right, and so in this case, we are going to do a dashed line. So it's usually easier to do this with a straight edge and then just dash all the way down. So we're going to do some of these graphing. All right. All right, so we have the line itself, but now we need to say y is greater than that line. Well, where is y greater than the line? So the best way to do this is to find your y-intercept. Which part of this would be greater than or less than? Well, above it, right? But I'm talking about every single point on the graph that is larger than a y value on the line. Here's a good place to decide which side of the line I'm going to shade. We're actually going to shade this just like we shaded our number line. I'm going to look at my y-intercept. I'm going to say, here's the 3. Y is supposed to be bigger, so it's going to be this side of the line. And everywhere on this side of the line would represent numbers that are larger than the y value being larger than that 2x plus 3. And so when I shade this, I'm actually going to shade my coordinate plane. Whereas when I had a number line, I just shaded the number line. Now I have an entire coordinate plane to shade. And the y-intercept tells me which side of the line to shade. I look at this guy, I say y is supposed to be bigger than that. So I'm going to do the side of the line that includes that part that is bigger. How do I know I did it right? Well, you can choose a point and you can test it. I can go over here and I can choose a point that's over here. Let's say the point 3, 0, right? Everybody agree that's in my shading? That's the point 3, 0. So I'm going to see, well, does that actually work? Y is the 0 greater than -2 times my x was 3 plus 3. 0 is larger than -6 plus 3. 0 is larger than -3. That is true. All right, so if I wanted to check, did I shade the right part? I can pick any point in my shading and decide, does that give me a true statement if I were to plug it into my inequality? So my answer here is actually the graph itself. My answer here is actually the graph. I'm going to graph the line. I'm going to decide if it is solid or if it is dashed. And then I'm going to decide which side of the line should be shaded based on whether it's greater than or less than. All right, any questions on that? This says to use the point 0, 0. This is an easy point to use, but if I used it here, 0, 0 should give me a false statement, all right, because it's not part of my answer. So I typically choose one that is part of my answer, and I check it that way. All right, I want you to try one. The first one, too, is just saying, tell me if it is a solid or a dashed line. The second one, I actually want you to graph. So the first one, just tell me if it's solid or dashed. You don't have to actually graph it. The second one, I want you to actually graph for these. So the first one, was it solid or dashed? Dashed. Yeah, this one was dashed. So let's graph this one. And I went off my graph just a little bit. That's okay. So I am going to start at my -6, right? And I'm going to go up 2 and over 1. And this particular one is solid, right? Because it's an or equal to. So my line looks like this, all right? And then I'm going to go over here and I'm going to look at my sign. My sign here is greater than or equal to. So this is why I use my y-intercept. I find my y-intercept and I say, which side of the line does the graph fall that would be larger than this? This is -6. Which side is larger? Or this part of it's larger, right? If it were smaller, I would actually be down here. So if this side is larger, then everything on this side of the line is going to be shaded. So I always go to my y-intercept because it's saying y is bigger than that. So wherever that side of the y-axis falls that's larger than that, that whole side of the line will be shaded. So for this one, the whole side of this line will be shaded with my shading right here. Okay. So you can think of it as like above the line and below the line, but sometimes when it's really steep, it's hard to tell what's above and below. And so you can go back to your y-intercept and say -6 is here. So -5, -4, all the numbers bigger than -6 fall on this side of my blue line. So I'm going to shade this side of my blue line. Y is bigger than that. I'm shading Y. It says graphing an inequality. Solve for Y and identify the slope and the y-intercept with the corresponding equality. Graph. If it is greater than or less than, use a dashed line. It is greater than or equal to or less than or equal to, use a solid line. Choose a test point that is not on the line and substitute it. That is to check your work. All right. You can choose a point to see which way to shade, but the best point to choose is your y-intercept. That's the best way to see, since we're going to put it in slope-intercept form. So let's look at example 2. Example 2. It says graph 6x minus 2y, which is greater than or equal to -10. All right, so we're going to say we want it in slope-intercept form. So the first thing we're going to do is we're going to move our 6 over. Don't forget there's a -2 with that y. So it's -2y. It is still greater than or equal to. And then we have -6x minus 10. My last step here to get it in slope-intercept is to divide by -2. And I have to divide every single piece of this by -2. So on the left-hand side, I have my y by itself, but I divided by a negative. So I have to flip that to a less than or equal to sign. -6 divided by -2 is positive 3x. -10 divided by -2 is positive 5. All right, positive 5. So now I'm going to graph this. I am going to go to the positive side 5 first. My slope is 3 over 1. In this case, positive 3 movement is going to bump me off the graph. So remember, I can also do negative over negative. That's also a positive slope, right? So I can actually go down 1, 2, 3, and left 1. And that's also going to give me a positive slope. So I have my 2 points. Now I decide, is it solid or dashed? Well, according to this, it's going to be solid. So I am going to draw a solid line between those 2 points. And once I have my solid line, I need to decide which side of the graph I need to shade. All right? So I know it's less than, right? Everybody see that? Less than. I'm going to go to this positive 5. Which side of the line makes my y's less than 5? Well, 4, 3, 2, 1. It's going to be this side of the line. Everybody see that? So I always start at my y-intercept, okay? And I say less than. Y is less than that. Here's my positive 5. This side is less than 5 when I go on my y-axis. So I am going to shade the side that's less than 5. I'm going to shade over here. All right. So there is a time and a place to graph with y-intercepts and x-intercepts, okay? Most word problems are not in slope-intercept form. Every once in a while they are. Like, for example, it says it starts at this point and it increases, 2 for every whatever. Then that's usually a slope-intercept. Very often, though, they're not. They're in standard form. And so when it's in standard form, it's usually easier to graph by intercepts. So we're actually going to do one where we're graphing by intercepts. I will say this, though. When you graph like something like this, when you start reading the word problem, again, very often you will not need to use all the quadrants. And so when we read this word problem, we're probably going to stay just in my first quadrant, and we'll talk about why. It says Jessica's on a strict weight loss diet and wants to limit her total caloric intake from carbohydrates and fats to 720 calories each day. She gets the rest of her calories from protein. Each gram of carbohydrates contains 4 calories and each gram of fat contains 9 calories. Write and graph a linear inequality that models her plan. All right? So we have 2 things we're talking about. Those are going to be our variables. It says carbohydrates and fats. All right? So we have these 2. If you always use X and Y, that's perfectly fine. You just need to tell me what they stand for. All right? So anytime you create your own variables, you need to define them for me and for yourself so that you don't forget what you're talking about. So I would say, well, X is going to represent my grams of carbs. And I would write that Y is going to represent my grams of fat. So if my X values represent grams of carbs and Y represent grams of fat, I'm only going to use the first quadrant because I can't have a negative number of carbs and fats. That does not make sense logically, right? And so very often in word problems, you're restricted to the first quadrant because logic will not allow you to go to the negatives. If I'm talking about number of people, we don't have a negative number of people, right? Or time, we're not going to say negative time. So there are situations where word problems don't require anything except your positive, all right? And so that's why I'm just showing it here because we don't need anything else. The other thing that we're going to look at is how does this work? Well, what are we multiplying each of our grams of carbs by? Well, the number of calories. So I'm going to say if I need to figure out how many calories I'm doing, I have to multiply every gram of carb by 4. Because it said each gram contains 4 calories. And if I'm also including fat, each fat gram contains 9 calories. So I have to multiply each of those by 9. And she wants to keep this under a certain number. What's that number? Right here. How do I write under a number? Less than. And actually it said limit it to. So it can be or equal to. Because she didn't say that she had to be under, that she wanted it limited to that. So it can also include that 720. Here's the thing. If I put this in slope-intercept form, I would have a really huge y-intercept and a little tiny slope. And so it's sometimes really hard to write, a y-intercept way up here and then go down 1 over 2 when your units are not going to be written that way. If I'm talking numbers this large, I'm not going to use 1, 2, 3, 4, 5 as my units, right? I'm probably going to use like 10, 20, 30, 40, 50, something like that. Makes more sense. And so this is a situation where I would graph by y and x intercepts. So we have to recall, how do I find it? Well, the x-intercept, I'm just going to take this 720 and I'm going to divide by the number in front of my x. All right? So if I take 720 and divide by x, 4 goes into 7. 1 time, 4 goes into 32, which is what's left over, 8 times with a 0. So my x-intercept is going to happen here. Y-intercept, well, how do I find that? I take that same 720 and I divide by the number in front of my y. And so that one is going to be 72 divided by 9. That's a little bit easier. That's going to be 80 for that one. So you see why I'm not going to go in units of 1. I would have to draw a really huge graph if I went by ones, okay? And so they actually went by even a larger number than 10. They went by something like 50. I'm going to go by 20s, all right? And so if I am graphing these, I'm going to go on the x-axis all the way to 180. Well, if these are 20s, that's, keep in mind what I'm doing here. If I'm graphing by 20s, maybe a good idea to write it out. So this is 20, 40, 60, 80, and so on. So when you have a large word problem, you may need to adjust what your units are. I need to go to 180 on the x-axis. That's right here. And then for the y-intercept, this is going to be the same thing. And actually, you don't even, when you're doing word problems, you don't even necessarily have to have them in the same units, but in this case we can. 80 is going to be where I go on my y-axis, all right? So I now have 2 points for my line. I can graph it. I'm going to do the same thing at this point. So once I get my two intercepts, I'm going to decide is this solid or dashed. In this case, this guy's going to be solid. So I'm going to connect those two dots with a solid line, all right? Solid line. Now, here's the thing when it's in standard form. This is my equation right here, right? It's in standard form. Do I have a greater than or a less than? Less than, right? So normally I would say, oh, well, here it is. Let's go less than. I have to check one more thing when it's in standard form. I have to look and see what is the sign in front of the guy with my y. Okay? This is a positive. So I would actually keep this as a less than. But why does it matter? If this were a negative, why does it matter that I need to check that? What would happen to this sign if I put it in slope-intercept form and there was a negative right here? When I divide by that number in front of my y, this would flip, okay? So when it's in standard form, your solid and dashed is exactly the same. But you have to take a double take and say, hang on, I know it says less than, but if I were to put it in slope-intercept form, would it flip? And if it would flip, you have to graph it the way it would flip, okay? So this one will not flip. I can graph it exactly the same way. This is going to be where she needs to keep her fat and carb grams. What does that tell her? Well, that tells her I can do anything on the line or below it, and I will be staying within the capacity that I want to stay within, right? And this is what businesses do as well. They will say, we want to make sure that we sell this many units at this price, and they're going to actually graph it and say, we have to stay within this graph to meet our requirements that we want, okay? So this is going to be used in lots of places where they make sure they're staying within some guidelines that they set up. But there's a lot of different combinations that meet those guidelines, right? She could decide she wants a ton of carbs this week, which is right here, which means she's going to have to do what to her fat? Well, as the carbs go up, what's happening to the fat? They're going down, right? Or she could say, no, I'm going to eat lots of bacon this week, so I'm going to reduce my carbs. So it's going to help her with whatever she wants and any combination of what she wants. It's going to give her combinations there. Trey earns commission, $25 on each computer and $5 on each calculator. What are our two variables?
Calculator.
Right, so I'm going to set up variables for calculators and computers. So my first one that they listed was computer. I'm just going to go in that order. The second one they listed was calculator. So the first thing that you need to figure out is what your variables are. Computer, calculator. And then you need to go back and say, what am I multiplying each computer by? What am I multiplying each calculator by? And then do I need to set up a less than or equal to the total that they've given me? So go ahead and set up an inequality for this one, and then we'll graph it. You would have multiplied each computer by $25. That's what he makes on that. Plus each calculator by $5. He needs to make at least, is $325 the most that he wants to make or the minimum? So what he makes needs to be larger than $325. So you have to look for the logic behind this. If he wants to make at least, then that means this needs to be greater than or equal to 325. All right? And then I'm going to do it exactly the same way. If I want to find my x-intercept, my x-intercept is just going to be that 325 divided by the 25, right? What is 325 divided by 25? Right, so it goes in 12 plus one more. So it's going to be 13 for that. And then my y-intercept is going to be that 325 divided by the 5. So my y-intercept is going to be what? 65, all right? If I wanted to graph this, I'm going to need to use something other than ones. So even if I made it tens, that's going to work, right? And like I said, if you don't want to do the bottom with tens, you don't have to. You can do the bottom in a different unit. I could have done the bottom by fives if I had wanted to. They don't have to be in the same unit because you're talking about two different things, all right? Then you're going to graph it. 65 is my y, 13 is my x. I'm going to do a solid line there. And then I'm going to decide, is it above or below that line? Well, it's greater than or equal to. Do I have a positive in front of my y? Yes. So it's going to stay greater than or equal to. So I'm going to shade everything up here. As long as he's on the line or above it, he will make his $325 or more for the week.